Okay, so let's begin some application problems. So we know how the relationship between position, velocity, and acceleration. And the fact I want you to know is when an object is thrown up, it reaches its maximum height, right, when the velocity is equal to 0. All right, so here's the position function of, in meters. If it's being thrown up from the ground on the moon, what's the time needed? The time needed to reach the maximum. So that is an application right there of us setting the derivative equal to 0. So I'll get negative 27 over 10 times 2t plus 27. So I'll set that equal to 0. So it'll give me negative 27 over 5t equal negative 27. So t will equal 5. So that's the time that it takes to reach the maximum height, 5 seconds. So then what is the maximum height? To find the maximum height, I'm going to put that back into the position function, because that's what the position function does, is it tells me the height. So I get plus 27 times 5 plus 6. So that'll give me 50. So it gives me 62.5 plus 141. So 203.5 meters. So that's how high it is. Okay, so let's talk about when something is moving in the positive direction. That means it's moving up or to the right. And so on the graph of the velocity, that would be above the x-axis. So if I was to draw the velocity function, when it's above the x-axis, y values, or above the t-axis where the y values are positive, that's when it's moving in the positive direction. When something is moving in the negative direction, that would be when the velocity is less than 0 or below the x-axis or the t-axis. Okay, so let's talk about these functions, because I'm going to give you things that are relatively easy to graph even without a graphing calculator. So you know that this can be written as t minus 1. So it crosses here at 0 and crosses here at 1. So this is the v of t, the y, and this is the t. So when is this moving in the positive direction? So it's moving in the positive direction when v of t is bigger than 0. So that would be negative infinity. So the answer to A, negative infinity to 0, and then 1 to infinity. And when is it moving in the negative direction? That would be from 0 to 1. Okay, so, oops, forgot to draw the s of t in here. So let's do that. So let's go to 2 and 4 and 6. Okay, so when is this moving in the positive direction? And when is it moving in the negative direction? So this is the s of t, right? So if I was to draw the velocity graph, so I would want to find out when the slope is 0. So slope is 0 at 2, and slope is 0 at 4. And I drew a little flat spot at 6, but it didn't change direction, right? Okay, so it's positive slope before 2, so that's above the x-axis. Negative slope between 2 and 4. Positive slope to 6, little flat spot, and then it went back up again, right? So slope, and then, yeah, anyway, okay. So that's my v of t. So when is it moving in the positive direction? Positive direction from 0 to 2, and 4 to 6, and in the negative direction between 2 and 4. All right, so now we're looking at, actually, let me come back and do this on the next video.